Hello, I welcome you all to this another interesting screencast, and the problem reads: three parallel bolting forces act on the circular plate. Determine the resultant force. Specify its location on the plate. FA, FB, and FC is given. In the second case, the three parallel bolting forces act on the circular plate. If force at A has a magnitude of FA equal to 200 pounds, determine the magnitudes of FB and FC, so that the resultant force FR of the system has a line of action that coincides with the y-axis. Both these problems are coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. You can solve this particular problem either by using the scalar or the vector approaches, okay? Or you can combine the two approaches together. It's really up to you. So for me, I'm going to combine the two approaches, okay? It is up to you which approach to use. So the scalar itself will look something like this. So the scalar, you'll have, let's say you have the resultant force FRY, and let's say you want the position in the x-axis, let's call it dx. This is going to be equal to the summation of moments about the z-axis. And then FRY times the position in the y-axis, this is going to be equal to summation of moments about the x-axis. This is the scalar. And for the vector, all right, we need to represent this as a vector. So let's say we have the position to the resultant force. We are going to call R. We have the moment arm to the resultant force R. Okay, moment arm. Then R cross the resultant force. So this is going to be equal to the summation of the resultant moment, where the resultant moment is equal to RA cross FA plus RB cross FB plus RC cross FC. Really, it's up to you which method to use. I'm going to combine both of them. All right. So let's call this is case 4-128. Okay, so I'll combine the two approaches, scalar and so let's assume the position of a resultant force. We'll just assume it there as positive. Not that it's positive, we're just assuming we'll change its direction. Okay, all right, so let's say it is there like so. So let's call this as, and then let's say this one there. All right, so this one is equal to FRY, and then this one is equal to this is the moment arm. Okay, so from this we're going to say let's look for the positions for this. We say the positions for this. Let's draw the position for this. Let's use blue. We say something like so, something like so, something like so. All right, okay, something like so, something like so. Okay, so there we go. So these are the positions. We need these positions for these particular forces as we take the moments. All right, like I said, I'm going to combine the two methods. So this one is equal to this is 1.5 sine 45. Okay, so let me write it in advance. I think I will need to write it in advance. I need to give it the value in advance. This is 1.5 sine 45, I'll put 4 decimal places, 0.00607. Alright, this one is equal to 1.5 cos 45. Cos 45 and sin 45 are the same, so this is 1067, like so. Okay, and then this is 1.5 cos 30, which is equal to 0.75, right? Of course, because no, this is not 0.75, sorry. Cos 30 is something else, unless sin 30. Cos 30, this is 1.2, 1.3. This is 1.30. This one is the one which is 1.5 sine 30, which is equal to 0.75. Alright, so we have all that information now. We can go ahead. We said let's find the summation of forces in the y, summation of forces in the y, and then this is going to be equal to FRY, which is equal to FA plus FB plus FC. Okay, and then FA is already given. FA is equal to 200 pounds. FB is equal to 100 pounds, and FC is equal to 400 pounds. Therefore, FRY is just going to be equal to so it's going in the negative direction. 200 plus 100, that's 300, plus 400, that's 700, so 700 pounds. Alright, and then our moment arm, FR, like so, this is just going to be equal to the position. So let's call it like, we're going to call this position is unknown. So as unknown, we are going to do this. Let's do this. Okay, let's do this. All right. So this one, we'll call it as our it's in the x. All right, let's just call it as dx. And then this one, let's call it as dy. I mean dz. This one is dx. This one is dz. Great. Therefore, this is just going to be equal to dx plus dxi plus dzk. Alright, so let's now multiply them. I think we have everything. We can also write the moment. Let's write the moment as a vector. I'm going to use the scalar. So let's find moments about the x-axis. I'll use the right hand thumb rule. So I'm mixing the scalar way of working it out, writing it as in vector Cartesian form. So FA is going to cause a negative moment. FA and FB is going to cause a negative moment about the x-axis. So I'll have what do we have? What is FA? So we'll have FA, so it's negative FA by the lever arm, which is 1.0607, okay, and minus FB by the lever arm, which is 0.75. Okay, and this is I. Then plus about the z-axis. So we have positive from FA. So we'll have FA by the lever arm, which is 1.0607, and then we have negative from FB. Oh, sorry, there is an FC there also. FC is participating. How did I forget about FC? FC is causing a positive, so we'll have FC by 1.5. Okay, this is I. Then plus, we are saying positive FA by 1.0607, and then we have a negative FB by 1.30. Okay, all right, so this is our expression. So equate the two. We are going to equate the two. So say RA FR, like so. FR, I mean sorry, RR cross FRY. This is supposed to be equal to the summation of this moment. Okay, so we are going to work it out. Let's plug in figures. So if you plugged in figures, okay, this will give us, let me write a complete one here. So we have dxi plus dzk, okay, cross this, writing it as a vector. If we are to write this as a vector, this becomes FRY as a vector. This is just going to be equal to negative 700 J. Okay, all right. So this is as a vector. So this is just going to be equal to minus 700 J. Okay, is going to be equal to, let's plug in figures in there. FA we said is 200, so minus 200 times 1.0607 minus FB, which is 100 times 0.75 plus FC, which is 400 times 1.5. So this one gives us a 312.86I. Okay. Can I just go through it again? Minus 200 by 1.0607 minus 100 by 0.75 plus 400 by 1.5. All right, 312.86, great. Then the other one, FA, is 200 by 1.0607 minus FB, which is 100 by 1.3. So this one gives us a plus 82.14K. Okay, 200 by 1.0607 minus 100 by 1.3, 82.14. Okay, so this is what this part is supposed to equal at that moment there, right? That's what we said our equation. Our equation that we're using is we are using this equation. We are saying R, which is the moment arm, R subscript R cross the resultant is supposed to be equal to the summation of the resultant moment. Okay, this is the resultant moment. Great. So we have this part. So I'm going to use, instead of drawing this, okay, I feel sometimes it consumes time, so I'm going to just use, we have I, J, K. Okay, so we have I, J, K. So I'll move like so, like this, like this. So I times J is K, I cross J is K, K cross I is J. But J cross I becomes negative K, right? Okay, so let's do that. So dxi cross J, so I cross J is what? Is K. So this just becomes minus 700 dx what? Dx K. Okay, K, right? So I, J, K. All right. And then dzk by 700j. So it is k by j. It's in the opposite direction, so it has to be a minus. So minus by minus becomes a plus, so therefore we'll have a plus there. Then 700 dzk. I mean dz, this is k by dzi, sorry, dzi, like so. Alright, it's k by j in the opposite direction, so it will give us I, but the sign will change, so this minus will disappear. So this is equal to 312.86 I plus 82.14 this. So we're going to now equate parts that are equal. This part, equate the parts that are in the same direction. This part, we equate it with this, and then this part we equate it with this. All right, and then make those unknown subject of the formula, right? Great. So we'll have two equations. So here we are going to have a minus 700 dx, which will be equal to 82.14, and therefore dx is just going to be equal to, you make dx subject of formula, so we have 82 divided by 700, so we'll have minus 0.11, I'll maintain 4 decimal places, 73. What are units here? These are feet, right? Yes, feet. Great. Then this other part here, we'll have another equation, which is 700 dz will be equal to 312.86. Therefore, dz is just going to be equal to 312.86 divided by 700. So this gives us 0.4469 feet. Okay, so this is the advantage of using vector way of working out problems like this in 3D. They will give you the exact position with the signs. If we were to use the scalar, you need to always have the sense of direction, all right, for you to know the position. But they still give us the similar results. It's really up to you to choose which method you want to use. Okay, so dx in the x, it means of course it is in this direction, all right. So we have that point, and then dz positive, so you mean it's going to be, let's say somewhere, you can even say somewhere there. Okay, dz is a bigger value while in dx is a smaller value, right? So somewhere there. All right, so those are the positions. I'll not indicate it there. because we don't have too much space. So we'll go to case number 2. We are going to go to case number 2, which is case 4-129. 4-129. And here they're asking us to find FB and FC. Alright, given FA. And they've told us that the load is supposed to coincide with the y-axis. So they are saying the load is supposed to coincide with the y-axis in this direction. Alright. So if that is the case, if the resultant force is supposed to be in this direction, alright, then it means the lever arms are going to be equal to what? 0. Alright. So if this happens, therefore, in this particular case, we'll say our dx is going to be equal to what? 0. And our dy is going to be equal to what? 0. So we use the same equation. Alright, we use the same equation. Then we'll have the new resultant force. Not really. The resultant force has only one component, which is one known component, which is 200, and the others they will be unknown. So our resultant moment will have unknowns in them. All right. So the same equation, we are using the same equation, the same resultant. So we'll say our resultant moment summation over the resultant moment using the same equation, this equation here, seeing this equation, using this equation, this is the same equation we're using here, right? We're using this equation. Let me just draw it. So we're using this same equation. So this equation is the same one we want to use here. Okay. So using the same equation, we are going to say FA, of course, is given. So we can work it out. So FA is 200, right? FA we've been told is equal to 200. FA is equal to 200 pounds. So it will appear in our equation. So we'll have minus 200 by 1.667 like so. So we'll have a minus 212.14. Then the rest will just be unknown. 0.75 FB plus 1.5 FC. Okay. So this will be our I. Okay. And then in the second case, we have a plus. FA again there is known. It's also going to be equal to 212.14 minus 1.3 FB. Okay. And then we said this part dx I plus dz k, okay, cross the resultant, okay, cross the resultant, and we know the resultant is just 200 minus 200, okay, plus FB plus FC. This is going to be equal to what? 0. Okay, why? Because this part is equal to 0 and this part is equal to 0, because the resultant is this resultant. This is the resultant. All right. This resultant is this one. It has a J there. Let me just put a J like so. Okay. So this resultant is coinciding with the y-axis. All right. But the lever arms are all equal to what? 0. Lever arm about the y-axis. Lever arm with respect to the z and the x-axis are all equal to what? 0. Great. Okay, so let me put the J there because we are representing this as a vector. So now, therefore, the summation of this moment FRR is just all equal to what? 0, both in the x-axis and in the y-axis. And if this is the case, therefore we are going to extract two equations there. One of the equations will be 212.14 minus 0.75 FB plus 1.5 FC is going to be equal to 0. Alright, so 0, okay, in the x-axis there, the moment, and the other equation is 212.14 minus 1.3 FB is also going to be equal to 0 in the z-axis. So if this is the case, FB here will be equal to, we can work out FB. FB will be equal to 212.14 divided by 1.3, and FB we get 163.18. And once we find this, then we can find what FC is, because we just we're just going to replace our FB. So we'll replace this one here, we'll replace this one there. Okay, so let's do so. Let me just go through again. Oh, great. So 163.18. I'll write the whole, I'll not round it off because I have it on my calculator, it was long. So I'll use 1.163.1846154, okay, the longer part. This is what I'm going to use here in replacing, because I have it in my calculator to just save the accuracy of the final solution. So this is the one I'll replace there. So I'll say that times minus 0.75 so 212.14 divided by 1.3 times 0.75 minus 212.14 then divided by 0.11 divided by 1.5. So we find that our FC is equal to 223.02 pounds. Yeah, so let me just move these parts. I move them a little bit, maybe up to somewhere there. Great. And then let me rub out this part here. Great. I think we are done. Let me just enclose my final solutions. Where am I? So I have this position for resultant, okay, dx and dz, okay, in the xz plane, and then we have the values of FC they are given, okay, that's 223.02, and FB there, which is 163.18. I think this is about it. And I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and see you in my next screencast.